Good morning, everyone. This is Randy at the Central Region Headquarters. Thanks for joining today. We have what I think is a really special edition of the Wednesday Guest Speaker Series, looking back at the epic December 15, 16, 2021 storm that impacted so much of our region. We have a bunch of offices speaking today. We have 9 different presentations we're going to go through to look back at this really historic event from different perspectives from a variety of impacts in WFOs. But first off, we're going to start off with Andy Just from Central Region STI to kind of give us an overview, and then we'll go into the ROC and then the individual office presentations. So Andy, go ahead and take it away. The floor is yours.
All right, thank you, Randy, and good morning to everyone. So yeah, we're going to look at this as just a really quick science overview of this quote unquote megastorm, as we've called it here. Yeah, it brought a plethora of high impact events. You're going to hear about all that as we go through each talk. So, you know, I try to make a hand-drawn graphic here of all the various hazards that this event brought us, anywhere from mountain snow and various squalls across Colorado, and then a big swath of high winds, a lot of non-convective strong winds, and that resulted in a lot of blowing dust and some fires. And you had, of course, severe thunderstorms and tornadoes in the warm sector of the storm, very anomalous so far north. So what led to all this? Well, you know, this storm was very well progged ahead of time. You know, if you went and used some of the cluster analysis, you know, a tool that we've been, you know, trying to have everybody kind of utilize, if you will, in the forecast process in terms of especially the kind of extended time range. You know, you see it here clearly, very anomalous trough ridge pattern, just so set up to have a significant event, and that's exactly again what happened. If you look at another indice, one of my favorites, as I've noted in previous webinars as well as science sharing presentations, the European Extreme Forecast Index. You can go across a variety of different parameters. Here I'm showing the max temperature, unseasonably high warmth with an SOT of 2. You know, you're talking record warmth, which is something that was observed that day. The winds, wind gusts here is, you know, you're at the top end here with some of the EFI and SOT numbers, and then even given how warm and such a moist atmosphere coming up on top of all that wind, you actually saw some decent anomalies here for the Extreme Forecast Index and the Cape and the shift of tails for the Cape Shear, representative of such a dynamic both and thermodynamic atmosphere in place across a good chunk of the region. You know, this was a really good opportunity to utilize some of the NBM version 4.1 wind gust potentials. And here I've grabbed a couple of snapshots of what the peak gusts of greater than 48 knots look like for December 15th. You know, hit a lot of these areas over the plains that would see very high-end wind gusts, especially eastern Colorado and western Kansas. And then furthermore, as it got into the Great Lakes region on the 16th, experiencing various areas of very strong winds. Something else that was going on during this time period was a lot of you know, continuing dry conditions, especially to the soil moisture. So NASA's Land Information System, they have some various graphics for that, and here you can see all these values are just really low amounts of moisture in that top 4 inches, just favorable for both, you know, a blow and dust concern as well as the fire weather aspect. So if you look at just really quick on what happened, again, you saw this negative tilt trough lift through the upper Midwest with that really anomalous relative to climatology, you know, wind fields. You see these corridors, especially you get to like 0Z, it was intensifying, it was lifting northwards. Your 700 and 850 winds, you know, way off any of the climatology. So you know something bad is going to happen with that. You saw a really impressive atmospheric river develop, especially up over the upper Midwest as that intensifying negative tilt trough approached. And then even you go into the precipitable water aspect here too, you're looking at all outside of climatology with that. So this concludes the science aspect, and I will pass it back to you, Randy, to begin the various, probably do it from the rock side.
Thanks, Andy. Yeah, if you have any questions, please raise your hand or type them in the questions pane. I did mention at the top, we'll kind of play it by ear as far as timing goes. If we have time for questions after each presentation, we'll do that for a couple minutes. Otherwise, we'll kind of have an open discussion at the end. So if you have any questions during any of the presentations, please raise your hand, or comments, raise your hand or type in the questions. So with that, let's move on to, so there's a question, Andy, where can we find the story map? I'm gonna put it in the chat. Okay. So Andy's gonna drop it in the chat. Thank you, Andy. Let's move on to Chris Franks, and the rock plays such a key role for us in these big events, especially events that impact many offices and have such a footprint that is large as a storm like this. So Chris, I will turn it over to you to give the rock perspective. Thank you.
All right, hopefully everyone can see my Street Fighter screen here.
It looks great.
Okay. I found the cheesiest clip art tornadoes I could find on the web, probably from one of our old websites somewhere. But I realize this talk is December 15th, 16th, but from the rock perspective, we thought it'd be a little bit more valuable to talk about this event in comparison and contrast to the December 10th and 11th event, which was obviously a very significant long track tornado. There were several long track tornadoes that had affected a different portion of the region, obviously. But it was night and day difference in terms of the impact to rock operations, and I'll get into that here. So we were dealing with an army of tornadoes, and I think it's a little simplistic to say we had one EF4, but we actually had several. But that'll be the goal of my talk here today. So we had two historic events, right? We had we're going to hear a lot about the details of December 15th and 16th, but from the rock perspective, we are interested in how we did to support our key stakeholders, which is our FEMA regions, our field offices, and our leadership. So when we go back and look at these storms, we're interested. Now, obviously, we're not doing forecasting, but we're interested in our communication methods, our collaboration, our coordination, and how did we enable our offices or help enable our offices to succeed, and what we could do better maybe the next time around. So we were still pretty deep into the response to the December 10th and 11th event when December 15th rolled around. So I wanted to highlight the tracks on the right-hand side of the screen. The damage surveys on 10th and 11th were incredibly involved and significant, and I'll go into a little bit more detail. But it's really important here. I drew the regional boundary, which adds definitely a layer of complexity and coordination and collaboration as these storms cross from southern region offices into central region offices into Paducah and Louisville's area. Also, I know we'll hear about from our Kansas offices, but there was a pretty significant fire weather and high wind component with the December 15th event. In fact, Ken Harding, as I was staffed the rock, we had several people on during the 15th event, but as I was staffed the rock, Ken Harding was finishing I believe it was a field ops management course he was speaking at, and he strolled into the rock, and we had the situational awareness monitors on, and we were watching the fires burn in Kansas. And of course, there was a tremendous amount of warnings, convective warnings going out. At that point, we hadn't heard of a lot of damage, and we sort of pontificated that the fires might be the biggest story of this event. It turns out it was the tornadoes, high winds, and fires. But it was watching these evolve. We weren't exactly sure what would be the big weather story as this system evolved. So we did two internal after-action reviews obviously for the 15th event and then the 10th and 11th event. And there was a pretty disparate comparison between the two. When it came to December 10th and 11th, we had 7 findings, 4 best practices, 9 recommendations, 9 action items. We reimagined how we would do operations after reviewing things. We created templates based on that event. And when you compare that to sort of the findings from December 15th, 16th, we had a couple things that we sort of came to conclusion and one recommendation. But our workload and what we learned from these 2 events was dramatically different. One of the big reasons, and not the only reason, I'll show you some of the other reasons, but one of the big reasons our workload from the ROC was so different between the 2 is that the severe weather, the December 15th, 16th event, fire, severe, and wind, was definitely the local and regional stories, and it did get some national play, but it was nothing compared to the national and international attention that was sort of directed at Kentucky in the aftermath of Mayfield. The Quad State or the Mayfield, that was referred to many different things. So here's just one of the New York Times articles that we provided interviews for along with the offices. One of the things I wanted to bring up is that when we move into level 2 operations in the ROC, we spin up a regional action plan. And so this was day 2 of 7. We spun one up immediately when we went to level 2 as the event was sort of unfolding. This is the day after. And this is how we track all our activities. So, talking points, who's the lead, we have completion status. We in addition to the action plan, we spin up an ICS. So we'll bring in admin folks, we'll bring in science folks, we'll bring in other Central Region support staff to expand and depending on the level of support that's needed for the field or leadership. It's sometimes a tremendous undertaking to handle the taskers that come from, whether it's congressional affairs or the front office or NOAA or DOC level. It starts to really expand your workload. Just quickly touching on some of the key activities that we did for, again, the December 10th and 11th. We were involved in the significant event reporting at least once a day for a few days. Right when the Mayfield tornado struck, we constructed some preliminary damage tracks. We send those to our FEMA partners and our NOAA FEMA liaisons so they can start getting assets lined up. We managed talking points. We also did this again, and kudos to the Des Moines office for kind of the nudge with the key messaging, especially as we started to really tally up the number of tornadoes as the surveys evolved in the 15th and 16th. But for the 10th and 11th event, we actually had to adapt our talking points, create a congressional affairs version for our John Sokich's offices, and then that also went up to the NOAA and DOC level. We were involved in civil air patrol requests, helping coordinate the quick response teams, so bringing in our damage survey experts from other offices. Almost immediately, we were getting pinged, and we also were proactive in a couple areas on getting our disaster or weather narratives for the disaster declarations in these really high-profile big events that have big impacts. The clock starts really fast on those because they want the president's signature and aid to arrive as soon as possible. So we've seen a sort of change in that tempo. These declarations can happen much faster than days or weeks in some other situations. Certainly the remote analyst and satellite damage assessment support, we approach that more from the coordination and collaboration side. We're involved in the inter-office travel support. This is where our regional action plans and bringing in the admin folks is a big part of our process. In these, obviously the local offices handle 95% of the media request workload, but for national sort of stories, public affairs will get hit from our national outlets, which then filter down to us. And if we think it's a request that should be handled by the local office, we'll certainly direct request as appropriate, but we can certainly, especially if it's a cross-regional or cross-office sort of interview, we'll handle those. I was off one day, and I think I did a Skype from my kitchen table with a Canadian network TV, so it was a sort of an all hands on deck approach at times. And then with the December 10th and 11th, we did spin up a Central Region landing page, really to feature and host all the different write-ups that were being produced by our local field offices. And then you got Pat Spoden there with the 60 Minutes interview. So again, this is, I know I'm leaning heavily into December 10th and 11th, just to really compare how different these events were. The December 15th, 16th event was busy for us, but really nothing compared to the collaboration and coordination that took place. And here's just an inter-office aid slide that sort of shows where the more heavily impacted offices were, but really the far-reaching support that extended across the entire region. So that really concludes my talk. I wanted to give it a pretty high-level approach here. But as you're listening to the talks today, and I think even with the next round, just sort of keep this question in mind. What opportunities are there for inter-office support or support from the ROC, and maybe where we can improve that. The whole region concept is something that's a really important initiative with our roadmap and in our region. So just keep that question in mind as you listen to the talks today. And that's all I have, Randy.
Hey, thanks, Chris. Outstanding. Any questions for Chris? Please raise your hand or type in the chat window. I think it was fascinating, Chris, to kind of see that. I mean, you guys play such a unique role, and kind of to see you kind of peel the onion back a little bit about the kind of support that you provide and the people you're interacting with. I think is outstanding. We do have one hand raised. Brian Berg, you are unmuted. You're self-muted, Brian. Not hearing anything. Brian, if you can type into the chat window, maybe that would be great. I did share the link to Andy's story map. I apologize, Andy couldn't share that with the whole group, so it didn't come across when I said it was going to earlier, but it should be available now. So let's go ahead. At this point, I don't see anything. Thanks, Chris, for the overview. We'll go to Matt Bunkers up in Rapid City. Matt, the screen sharing is coming your way. And like I said, we'll come back around and have discussion at the end of everybody's presentations and that sort of thing as well. So Matt, go ahead, the floor is yours.
All right, thanks, Randy. A big shout out first to Keith Sherburne, who put together more than 90% of the AAR and this presentation. So Rapid City, as you saw from the beginning slide from Andy, just was on the northwestern edge of this system. By way of background, we had very little snowfall here in the middle of December, which is somewhat unusual. We just had some, of course, the Black Hills, we had very little snow. Here's Rapid City, west of Rapid City. Almost no snow in the Black Hills, very unusual, and there had been some snow from a recent storm across the south. So by way of background, very little snow on the ground. We had a strong cold front, of course, that moved through with the classic well-mixed boundary layer, strong cold advection, kind of a classic wind setup. And then we had the so-called Venturi effect along the eastern side of the Black Hills, where the winds will kind of funnel and constrict and become even locally stronger. So that's just the background setup from where we're at. So to put this into context, we had been windy for a few months. This was the 7th high wind warning since October. This particular event was the 3rd day of 3 very windy days, this day being the most notable winds of the entire event. And then we also had some localized travel impacts due to winter precipitation. In 2 of our zones in southwestern South Dakota, we had a combination of high wind warning and winter weather advisory. But again, there was very little snow on the ground and not much snow expected with the system, with the main focus from our perspective being the winds. In terms of what happened, well, whenever you have an east-west interstate and northwest winds on the open plains, you're going to have semis and other high-profile vehicles blown over. This seems to happen every time we have winds greater than 60 miles an hour in our area, which is quite common actually. And then we also had a couple snow squall warnings in south central South Dakota. You can see from the webcam perspectives, very little snow on the ground, but when we had the snow showers move through, the visibility quickly dropped to very low values. Just to reiterate the winds, we had 5 wind gusts between 70 and 80 miles an hour, otherwise several greater than 60. And again, these were focused just to the east of Rapid City down toward south central South Dakota. In terms of what went well, we had really good lead time on our high wind event, our high wind warning, and we were messaging these strong winds for several days leading up to this event and trying to amplify this final event a little bit more because it was more substantial than the previous days. One of the tools that we like to use is the NBM 1D viewer. This is a time animation which we created. It's not available from the viewer, but it shows a very well predicted high wind event as it was approaching in time. So we saw this coming several days out and were able to use this to message that, yeah, it's been windy, but it's even going to be even windier on this December 15th. Along those lines, we also like to look at the HREF winds from, mostly we'll look at the mean winds, but in this case, we're looking at the minimum winds from the ensemble, the mean and the max. But one thing that stood out here, and we're going to look at the trends over the next couple runs, for the min winds, we had some values just barely reaching 55 to 60. For the mean, there are several areas, or I should say, a larger area of winds above 60 miles an hour here in the pink, right around, this would be centered on Rapid City and then to the east. But then when we looked at the next run on December 14th at 12Z, we see that even the minimum winds were showing an area of 60 miles per hour or greater over Rapid City and toward the east. So this gave us even more confidence that this would be a substantial wind event for the area. And then just the next run confirmed that trend was still hanging in there with minimum winds greater than 60 miles an hour. So very, very good signal for several days out, and from the ensembles showing a high-end wind event for us. In terms of what could be improved, again, we were really focusing on the wind because that was so substantial. We didn't have much snow on the ground at all leading up to this event. And so in terms of the winter weather, we're essentially just focusing on the weather. You know, the rain would be transitioning to snow and there would be minor accumulations. And we didn't really connect the dots to the really strong winds with even just a minor amount of snow having substantial impacts, as you can see on these webcam, or I should say these are from Twitter down on the lower right. We had high profile vehicles that were, and trailers and semis that were blown over, but they also at times encountered very low visibility, just with really light snow moving through with not necessarily snow squalls, but just some light snow behind the frontal passage. So the messaging, kind of connecting the dots between the wind and the light snow could definitely be improved. And that was one of the main findings that we noted. One thing that we could look at, this is looking at in retrospect, is the blizzard product, so-called blizzard product from the HREF. On the right panel is the true conditions for blizzard, a quarter-mile visibility, 35-mile-an-hour winds, which was showing some low probabilities of those conditions over south central South Dakota, and the snow squall warnings were issued for that area. And then if we relax those conditions a little bit, we see much higher probabilities for that area, but it didn't fully capture the extent of some lower visibilities that we saw back toward Rapid City as well as into Meade County. But certainly this was a tool that could highlight that potential. In terms of wind, what could be improved? Just showing here on the left, this image was part of our DSS packet or our weather story perhaps. So we focused on the values for the high winds, which was really good. But as we thought about this, it might even be helpful to show some of the past images where we have semis that have been blown over to kind of marry those impacts to the actual forecast of the wind. So that's something that kind of came out of this where we could potentially improve. And also possibly coming up with some methods or some ways to really discriminate these more typical high wind events we get, which are like 50 to 60 miles an hour, versus the really high ones where we're seeing winds of 70 to 80 miles per hour over a very large area. And then finally, we did issue a couple snow squall warnings, as I indicated, and we had some technical difficulties with those in terms of configuration on the NOAA weather radio. We were fortunate that our WarnGen focal point was actually working during this event and was able to quickly fix that. But one thing we noted in the AAR was that it would be helpful for things like this to be tested a little bit more beforehand, especially in terms of the infrastructure and disseminating these products. And I think offices have seen some issues with this over the last year or so as well. And then finally, because we had some of these impacts with the winds and the light snow, not necessarily meeting snow squall warnings over a broader area, sharing of information from our partners that showed the low visibility and the high winds and the blowovers was really helpful for us to get that message out for an event that was predominantly wind driven, but added in just a little bit of snowfall, and that definitely created some more notable impacts. And so that wraps up the UNR portion of this discussion.
Hey, thanks so much, Matt. Any questions or comments for Matt and the rest of Rapid City? Please raise your hand or type in the questions pane. We have a couple minutes here. We're doing great on time. Matt, one thing that stuck out to me, I like your emphasis where you talked about communicating really how anomalous the winds would be, right? And sharing kind of it's important for us to provide context, right? So I really like that you mentioned that this is not your typical high wind event. Do you have thoughts on how you guys might approach that in the future as far as sharing this is like truly an anomalous event?
Well, yes, we did have some discussion about this, at least a few of us, and I think it will be mentioned more at our outreach team meeting or social media team meeting. But one thing we are going to try to do, I think, is include actual pictures of semis blowing over on the interstate as we're, days leading up to the event. If we see this is going to be a big event, let's include these pictures now that we've had from the DOT and others that show these impacts. So that will kind of tie that impact to the same image that we show of the actual forecast of the high winds. So we think that would be a step in the right direction.
That's outstanding, Matt. I think, from a social science perspective, that's called visual priming, right? And being able to prime people to kind of what they might expect from the event with a picture is very powerful. For example, like in Winter Storm, showing, if you're in a bigger city, maybe not so much Rapid City, but put a picture of like a traffic backup, right? So that people can kind of get a visual of what the impacts might be for them if they're out trying to drive during a morning commute during a snowstorm or something like that. So I think really the visual priming is an outstanding idea. We do have a couple questions coming in, Matt, from John Gagan regarding the snow squall warning issue with NWR. Is there anything that can be shared so we can check our systems regarding the problems you had getting those to NWR?
John, I will have to check with Jeff Johnson, who is our focal point and who was working that evening. He may have some information to pass along.
Yeah, that would be great. Actually, Brian Bargenbrook asked basically the same question, so that would be great if you could share that with us, Matt.
Okay, I will look into that.
All right, super. Thanks so much, Matt, and for everybody at Rapid City that worked on this. Keith, you mentioned specifically, so thank you very much. We're going to move on to Pueblo and Paul Wall. Paul, I'm sharing, or asking you to share your screen at this time, so you should see that.
All right, can you hear me?
I can hear you, and we can see your screen, so the floor is yours, sir.
All right, good morning. I'm going to talk about the event from the Pueblo County warning area. We're not going to talk about it much, but there was heavy snow in the mountains of Colorado along the Continental Divide region. Wolf Creek Pass had 14 inches, which is a modest event for them. For an example, for the past 2 days, they've had 25 inches. So there was some snow in the Continental Divide region. We're going to mainly talk about the wind for today. And so the outline, we're going to talk about the sciences, the services, briefly about Alfred's culture, and then discuss our record wind gusts with this event. Our high winds actually resulted from 3 different processes. First, there was a line of weakening convection, and we had some strong wind gusts with that. As a matter of fact, the record wind gust at Lamar was associated with this convective wind line. Second, there was a pressure gradient. This was due to rapidly deepening cyclogenesis in northeast Colorado. And then the third process, there was a Bora wind event just in the lee of the mountains in El Paso County. That's where Colorado Springs is located. Here is the GFS initial field from the 18Z run on December 15th. Just want to discuss the couple features with this event that made it rather strong and unique. In the upper left-hand corner, here's the 500 millibar pattern. Here is Colorado right here. Notice a very strong trough that progressed across the region. And notice this is 18Z, that we have northwest flow developing behind the system with cold air continuing to funnel in the lower layers over the mountains, while aloft behind the trough there was subsidence. Also looking in the lower right at the surface pressure field, here's Colorado. Here's the deepening surface flow over northeast Colorado. And you can see the strong pressure gradient across the region. Also at this time, the winds at 700 millibars, which is like 850 millibars further east, for where you look at what's going on just above the surface, they were roughly 70 to 75 knots out of the west. This next image is a radar loop from Pueblo, starting at 1530 Z every 15 minutes and going to 1611 Z. If you notice, there is a convective line which moves across the region and out onto the eastern plains. Notice we had a severe thunderstorm warning out for high winds, even though there was very little, if any, lightning associated with this because of the rapid increase in winds and the strong winds associated with it. We issued some severe thunderstorm warnings. We called in a person at 4 to come in the office at 4 a.m. just to handle this convective line. Also, here is Lamar. I want to point out that actually the strongest wind at Lamar was associated with this convective line, and it occurred just when this outflow, this leading edge of the outflow you could sort of see right here, reached Lamar, is when they had their peak wind gust of 93 knots, which I believe is 107 miles an hour. Also going to talk about the Bora wind event up in Colorado Springs. Just want to point out, here's Colorado Springs. The airport's just about right here. And you can see there in the lee of the mountains, this rampart range roughly from 7,000 feet to 9,000, 9,500 feet. Here's Pikes Peak. This is a common area to get strong winds with these Bora type events. And here's Interstate 25, major north-south interstate. Colorado Springs is roughly 500,000. Denver area is roughly 2 million. So there's a lot of traffic on here. And we had roughly a dozen semi blowovers just on this track of the interstate. A good way to describe to show the three different effects is looking at the peak hourly wind gusts for 3 METAR sites. The blue line is La Junta, that is east of Pueblo on the eastern plains. The orange line's Colorado Springs, and the gray line is Pueblo. Now, notice early in the morning, especially Colorado Springs and Pueblo, the winds were light, and then all of a sudden, around the peak gust from 14 to 15 Z reached near 70 knots at Pueblo and roughly 53 knots at Colorado Springs. This was associated with the convective line. And then you could see an hour later, well, this is actually peak hourly wind gusts, so it would have been less than an hour later. You could see the peak wind gusts associated with the convective line at La Junta. And then after the convective line passed, actually the winds decreased. Peak hourly gust of 40 knots is still strong, but nothing spectacular. And then you could see the winds increase here associated with the deepening cyclone and the strong pressure gradient and the vertical mixing of momentum downward. And then then you could see here's Colorado Springs. Actually, the winds increased later on to a peak wind gust around 80 knots associated with the Bora wind event, where you could see the winds gradually were decreasing over the plains. So what went well with services? We saw this event many days in advance. I remember this was a Wednesday, and I remember working the mid-shift Sunday morning, and when I loaded in the NBM grids and saw that NBM4 was almost reaching high wind criteria already, we sort of had the idea that it was going to be a major event. Plus pattern recognition really also helped it. And here's for that Sunday afternoon, we already were playing it up in weather stories, talking about the threat for strong winds, heavy snow as well, and even bringing up something damage and about damaging winds. So we already on Sunday, we're starting to play this up. What went well, we also issued a DSS packet. We started 3 or 4 days beforehand issuing the packets, knowing this is going to be a major event. We held virtual briefings that were well received. On the day of the event, we had an open-ended virtual briefing room open all day. Our WCM Greg was in the office, and that was one of his main tasks, is just to be with the answering questions on virtual briefing. Plus, we had a log of reports. It really helped with the event summary and reports to the ROC. What can be improved? Maybe we should have started virtual briefings a day or two earlier, just not on the day of the event. We were kind of a little bit varying with the wind speed. Some of the runs were indicating 80 to 100 mile an hour wind gusts, while others were a little less. Maybe we should have been more consistent. Hindsight's always 20/20, but maybe we should have been a little more consistent with the stronger wind gusts. In the open-ended virtual briefing on the day of the event, maybe we should have been more structured. Greg was thinking maybe, every hour or so, just have a couple-minute formal briefing. The other thing we could have done better is we probably should have continued those severe thunderstorm warnings as the line moved across the eastern plains, even though no lightning was detected. Given the extreme event of the winds, which easily would have reached severe thunderstorm criteria, it probably would have been good. We could have had some more notice to the people besides our high wind warning of this burst of really strong winds coming through. And also Facebook Live would have been a really good tool, and we need more training on this. Office culture, what was really unique is here, this was the latest severe thunderstorm warning issued in our county warning area. By far, we don't really, any severe weather stops early October. We took innovative actions, continual virtual briefings, severe weather reports. Also, what worked really well, our telework support was really good on that day. They really helped with gathering storm reports, able to virtually run IRIS, also creating mesoscale graphics and then sending them to the office in our local chat room to be distributed was really helpful. And teleworking is really going to be great because it helps with the work-life balance where people were able to stay at home as well, but still contribute to the office during this major event. Here are some examples of mesographics that were issued early in the morning with discussing the convective line moving through first the Eastern Plain, the Interstate 25 corridor, then out onto the Eastern Plains. Finally, want to talk about the regional records. 100 mile an hour wind gust was the greatest ever reported at the Academy, which goes only back to year 2000. 92 mile an hour gust was the second strongest. 89 was the strongest reported ever in Pueblo, and the 107 in Lamar was the strongest ever reported. And 90 reports of 70 mile an hour winds were also reported throughout our county warning area. Just one note, after this, I did an analysis of the wind of ASOS for wind reports. And I discovered there's a high bias of wind reports towards the ASOS error. It seems that before ASOS, we were relying on the observers maybe to read the paper charts to put peak wind remarks in. And To be honest, that probably wasn't done religiously. Also, there were some coding errors, and I believe before 1973, there were no peak wind reports. So we have to take these records with a little bit of a grain of salt as far as being the strongest ever, but I definitely say that they were close to the strongest or the strongest over at least the last 25 years. That's all I have. Thank you, Randy. Any questions?
Thank you very much, Paul. That's a really interesting comment about the wind gusts in the ASOS era. If you have any questions for Paul, please raise your hand or type in the questions pane. I'm curious, Paul, how did the open briefing room go? And have you done that historically, having an open briefing room like that?
We did that the first time. I think it went well, that the people were there to, Greg was there to answer questions during this event. He wished, he's at a conference and he couldn't attend, do this talk, but he really wished that he would have done a more structured briefing every hour, just to give people up to date versus just being a totally open-ended. But I think it was well received, and having that communication with the people during this extreme event was a good thing.
Okay, great. Yeah, I mean, I love the idea, and I, just like as a weather service saying that we're here and we're available if you have any questions. It's kind of an open-ended conversation. So I love the idea. Another thing that kind of resonated with me was talking about the severes ended with the lack of lightning. And it's like one of those, like sometimes we think the best method, right, for setting off bells and whistles is to issue a severe in that case, obviously, because it's going to get more traction than a high wind warning. So is that like a topic of discussion in the office about, hey, it's convective whether there's lightning or not, right? We can issue the severe. Is that a kind of a conversation that's going on in the office after the event?
Yes, and I think given the extreme high end event it was, that probably would have been good just to get that alert out as well. Probably would have set off cell phones. I think, with the severe warnings, we probably would have set up cell phone if we put the more extreme wording in there, which would have been justified. I mean, before I came into work, I was in a building and it was calm, and all of a sudden, just when the front came, within a matter of 10 minutes, the whole building was just rattling. So it was really a pretty sudden increase in wind speed with that first convective line.
Awesome. Yeah, thanks so much, Paul, and for everybody else, a couple of that contributed it. Yeah, I remember watching the wind reports come out in your CWA that day, and they were pretty epic and amazing. So thanks so much.
Yeah, just one more comment. The NBM 4.1 actually did a decent job of this event, and that's in the AAR that we submitted, but actually did a decent job, so that was good. 4.1.
That is great to hear. Yeah, the wins in 4.1 are much improved over 4.0, so that's great to hear.
All right, thank you.
Yeah, thanks, Paul. Okay, we're going to move on to Jeremy in Goodland. So Jeremy, I'm sending the screen sharing to you. All right, looks great. Go ahead, the floor is yours.
All right, thank you. My name is Jeremy Martin. I am the SUO here in Goodland, and I'm just going to share some of our perspectives from this event. I'm not going to go into detail a lot of the meteorology behind it because I figured we've all seen it. We know it. I was mainly focused on what happened here in our office and how we responded to it. So in a nutshell, what happened is we basically had three things. We had damaging winds, we had a lot of dust, and we had wildfires. That's pretty much the story of this event for us. And every one of these were pretty high impact. It's funny, Paul mentioned the convective elements of that, I guess we'll say initial cold front. It was kind of enhanced by that convection. And you see that in that dust picture there. That was the leading edge of the strong winds and dust as it was coming into our CWA. And yeah, you did, in a lot of ways, looked like almost a summertime picture there. First off, we had high winds pretty much everywhere. The image on the right is just all the LSRs we issued for, severe winds. Every county had them, maybe except for the western portions of our CWA. And either that's, I'm not 100% sure that's because winds didn't happen or just we don't have a lot of obs out there. Our peak winds, we kind of came up short in some of these compared to what around us happened. We had one measured wind gusts of 90 miles an hour in Lenore, Kansas, which is in the eastern part of our CWA, 89, 87, several 84s, and pretty much everywhere got to about 70 miles an hour. But more interesting is if you strictly looked at wind damage reports, it definitely was confined more to, I would say, the southeast half of the CWA. There's some outliers there, but and that was where I haven't actually looked at it close enough to be sure, but apparently there was a sting jet of some sort that kind of went through that area, and that's coinciding with where all the wind damage reports came in later in the afternoon. Like I mentioned before, dust was a really big impact. The image on the left is just a snapshot of the RGB during the afternoon. You know, the dark magenta is essentially where the dust is. You can just see how much of western Kansas is covered in that right now. During this time, there's huge plumes all over the place. And if you look really closely on the leading edge of the cloud shield here, you can see that haze there too. And that was actually the initial surge of dust we had, followed by this kind of persistent, long-lasting dust that lasts most of the day. And the impacts that had, this is by the afternoon. And granted, this covers more than just my CWA, but in Kansas, you know, all these roads in red were closed, mainly due to the high winds and blowing dust. So it shut down pretty much every road in our area, and had I-70 closed at this time as far east as Russell. So it was a big impact. It essentially shut travel down for several hours. And we had wildfires, and I bet you'll see this wildfire perimeter graphic a few more times. We had, I believe, six reported fires in our CWA. The biggest was in southern Wichita County, which is just above the legend here in that image, which was about 7,500 acres. We had one in Graham County, which would be up here north of Quinter. It was 4,500 acres. We had one in Logan, was 3,200, and they gradually got smaller. If it wouldn't have been for the big monster, what they call Four Counties fire, further east of us, the South Wichita County one would have been the biggest one in the area. But unfortunately, or fortunately, it did not grow to the size of that monster fire just outside of our area did. So now I'm just going to go through kind of stuff, what we did. I basically have three positives and a couple things we could do better to talk about. And one thing I thought that really worked out well is like how we handled the dust storm methodology. As you may know or may not know, we have a couple products we can use. We have the dust storm warning, which is in a lot of ways similar to a severe thunderstorm warning. You know, it's polygon based. It alerts WIA and same codes, everything gets a lot of attention. We also have something called blowing dust warning, which is more of a long fused, almost kind of like a high wind warning. It doesn't same alert. It doesn't WIA. It's a warning, but it's not quite as high presence or priority as a dust storm warning. So what we chose to do, and we actually had some discussion about this before, and I was actually the warning operator on this in the morning, and I kind of came up with this at the beginning, and it seemed to work, so I think we're going to stick with it. How we did this is we wanted to make sure one thing, that everyone got a WIA alert as this dust storm was rolling in. At the same time, we wanted to make sure that they weren't getting constant WIA alerts all day in same messages, because at some point, once you're in the dust, you know it's there, you're not surprised by it anymore. So how we approached this was we decided we were going to issue all our dust storm warnings. They're going to be county based, and we did that not because we don't like polygons and not that polygons aren't useful, but we wanted to ensure that each county got that one and only one WIA and same alert, kind of avoid fatigue, because we were figuring this is going to be a long duration event. The second thing we were doing when we were issuing these is we wanted to limit the lead time to around 30 minutes, which seems odd. I mean, we had a pretty good idea this dust storm was coming for a while. We could have had a lot of lead time, but similar to tornadoes, you reach that point of if you warn somebody too far in advance, their response kind of diminishes. Because I can assure you from social media posts I saw after the fact and stuff, when you tell people dust storms coming, their first reaction is to go outside and look. And if it's still clear and looks nice, it misses something. But if they can look on the horizon and it looks nasty, that helps get a response from them. So that's why we tried to limit that. We also had the dust storm warnings go for 2 hours, or until we were reasonably sure. Sometimes a little bit longer if we thought it was going to take longer for that initial thing to get through, but these were moving so fast that really wasn't a concern. And then once that initial dust storm warning went through, it was going to expire, we'd replace it with the long fuse blowing dust warning in GFE. That way we could keep the wording, you know, conditions are bad, health impacts, visibility, but we weren't going to bombard people with WIAs anymore in same alerts, because at this point you weren't getting surprised by the dust. It was here, it was coming. And the image on the right is just an example of one of them we issued. You know, it's the radar obviously isn't that impressive at this. You can imagine that was that weak convection line that Paul was talking about. So we got out ahead of it with these county-based ones. And it worked out pretty well. Our POD was 93.7%. So we had 30 of the 32 dust storm events we had a dust storm warning out on it initially. Matter of fact, one of them I missed was because my first poly I put out wasn't county-based. And I learned really quick that was not a wise move. I cut it a little too close. We didn't have any false alarms, so every place we issued a dust storm warning got a WIA that it verified. Our first event lead time was about 20 minutes, which is what we were shooting for. Our average lead time was almost 45 minutes, and we had one maximum lead time of 109 minutes, which honestly was probably a bit too much. You know, it was probably based that I started making bigger polygons just to ease the workload a little bit. Another thing we did really well, we used pretty much every available mode of communication we had during this event. 800 megahertz, I don't know if everyone has that or not, which is like a direct connection to our first responders and EMs over the radio. We use that a lot. And in fact, we actually tied that in with this dust storm warning philosophy we did. Since we were purposely limiting lead time a little bit, what we did is we had our communicator. He would give the EMs and our first responders maybe like an hour and a half, 2 hour heads up that this was coming over 800 megahertz, you know, preparing when it was going to get there, all that thing. And then we would issue the warning when it was a little more imminent. That worked out really well. We got a lot of good feedback from that. We did have 2 webinars for this, Reef Corps partners. We did one in the morning before, and then we did one actually right before the onset of the event, about 8 o'clock in the morning, before when it was right on our doorstep. That was actually a really good one because we definitely could stop talking about things if they happen and start pointing to them and giving them specific timing. That was very well received. Something I did, and I've done this a few times now, and it seems like a popular way or an effective way to get a point across. I did a short, I mean like a minute and a half. I don't think it was any longer than that video clip. No graphics, no nothing, just me talking to the camera, explaining to them the magnitude of the event we were expecting and what it was going to be like out there if you were caught in it. I did this the day before. It was very well. It was shared a lot. We had a lot of views. I can't remember that total number. It seemed like it got the message across that this was something unique. It wasn't just your standard wind event. I think Matt mentioned this in his. You know, it's windy here all the time. Well, that's true, but not like this. And just that simple message and seeing a person telling them this seemed to resonate, at least with the people out here. One negative was people recognize me now. You know, Goodland's a small town, and it's been more than once I've been out and at Walmart and hear someone talk behind me and go, "Hey, that's that weather guy." So I guess that's a negative when you put yourself out there like that, but we all know each other out in this part of the world anyway. So, and then finally, we did do an open webinar, as others have mentioned, in the afternoon because there was a wind shift coming. You know, we had that initial, I guess, kind of Pacific front come through, and then we had the actual cold front coming through later. We did it. I was the one running that one. It's not the first time we have, but we kind of ran into that same problem that others have mentioned. That with no structure, it's really kind of hard. I'm not sure how much bang for the buck we got out of it. There's a lot of dead air. There's a lot of time of me just kind of filling time talking and not getting a lot of feedback. So that'd be something we need to look into more. How do we fine tune those? Because I've done this for this event. I did it for the Bankelman tornado day. We had a couple of big tornadoes. Yeah, people attended it and they seemed to like it, but I don't know, it didn't seem to be the most efficient use of time. And some other positives, the MBM 4.1, the probabilistic wind data was excellent. I'm sure we can get in there and say there was areas where it didn't do so well, and there were, like the sting jet area and stuff like that. But just having that data there, I can tell you one thing it did for me. When I came into work these set of shifts, it was my first shift. I had been off for a while. I was immediately changed, seeing that probabilistic data was able to change all of our wording. So I was no longer saying may happen or could happen. Everything changed to imminent. It will. Here's an example on the right. Strong winds imminent with the system. This is the day before. It really allowed us to get rid of all that uncertainty wording and say, no, this is going to be something significant. And there's not an if, it's more of a when. One thing the operations team that did that day is we kind of went into it with a plan. We discussed it the day before, and then we implemented it the day of, where they knew my philosophy on how I was going to issue dust storm warnings if we needed them. We knew how we were going to do, how we wanted to communicate things. Everyone kind of knew what the general plan was. So the other desks, like the social media and stuff, kind of know when to put new graphics out, because they knew when I was going to be doing something, for say issuing a new warning or something like that, because we had this game plan in place, and then that really worked out really well. As busy as it was, it went very, very smoothly. And finally, we coordinated with our support staff the day before about the possible power impacts. We're prone to lose power with all that wind. And thankfully we did, because we discovered we had a problem with our generator. It wasn't turning on automatically. And it would have knocked us completely offline if we would have lost power. So the technicians found it. They couldn't correct it in time, so we actually had the generator running ahead of time just to prevent that from happening. And I thought that was an excellent use of, we used our own forecast here to make sure we were ready. We did have some issues, especially with the fire weather side of the house. There's just one still shot of the ongoing fires during the storm. And this is before the real big one got going. One thing we're really gonna have to look into more is our current red flag warning criteria really reflective to the threat. If you judged it strictly by what our red flag criteria is, this event did not verify. It was a false alarm. And just based on all the fires, it's kind of hard to make the argument that this was not an extreme event. So we're going to look into maybe at the very least trying to augment a little bit more with something like the GFDI, maybe to help us in these edge cases. I'm not saying we're going to move to totally get rid of it, the criteria, but maybe have some augmentation with it. And this is probably more of a factor with our new emergency managers, but there was a lot of confusion on civil emergency messages and fire evacuation messages. The big fire in Wichita County that unfortunately had a fatality. I had to actually call them and offer to issue a fire warning because they didn't know what that was, or evacuation warning. They didn't know any of that stuff, what that was. We've rectified that and with some partner training afterwards, but that was an issue that we had to kind of teach them real time. And there was actually an evacuation order we found, and the only reason we ever found out about it was we saw it on a Facebook feed from one of the sheriffs. So we had to contact them, and then we got something issued. So it got more widespread coverage. This issue is something I've been kind of chewing on for several years. This isn't the first time we've had a bunch of wildfires in the middle of a dust storm. And if that's, is that some other kind of factor we're going to have to consider for our red flag warnings? Does this make this some kind of special kind of red flag warning when you have both hazards going on at once? Because as I mentioned this later on in this, there is some confusion with firefighters out there when they're fighting a fire in dust. It's smoky, there's dust. I was trying to coordinate a wind shift with Wichita County, and the fire people were saying it was moving. The fire was moving in the opposite direction that it certainly appeared to like it was. And all I could figure from that was, they're in the middle of this dust. They're disoriented. They can't really see very well in direction, and maybe they got things confused because the winds are blowing out of the north, and they thought the fire was growing to the north away from this small town, and it wasn't per satellite, and I could tell from winds. So that's something, or some type of event we're going to try to look more into, is this dust and fire combinations. This is the third time I can think of now where it's happened, where it's threatened a community as well. And finally, on the fire side, we also I learned the hard way, and I should have known this because I wrote this stuff. Those that use the Ghost Fire Alert banners, they won't work if there's dust going on, because the derived element I use masks out areas with dust, so it won't return a value. And I learned it the hard way again. So I'm going to make a note of that and try to find a way to fix that, or have a different detection method if there's a dust mask going on. But bear that in mind. You won't get those alerts of a wildfire detected if there's dust going on as well. And along with the dust thing too, this is kind of fascinating to me. And obviously I don't have enough data to prove it. But one of the fires in Logan County, our EM went back and checked out the whole fire burn area, because we all figured that all these fires were like down power lines. In that case, where the fire started, there wasn't a power line for miles, but it did seem like it started just downwind of an electric fence, a barbed wire fence. And after talking to some people who've been out along these during dust storms, is the theory is that static electricity from all the dust blowing across built up and discharged from the fence and started the fire, which is I guess something else we're gonna have to be worried about here in the future.
Hey, Jeremy, like one minute, okay? Okay,
sorry. Finally, this is the last slide I have. We had some other operational issues. The Wawa maps, they weren't displaying the dust storm warning legend on the map, and we've had a lot of ongoing problems with NIDS and not displaying dust products correctly. We had, similar to Paul mentioned, a little bit of variability in the messaging of the impacts of the events. We were kind of oscillating on magnitude. And other thing is we had some disagreement on what constitutes dust storm warning. So it's led to inconsistent service amongst the offices. I believe we were the only ones doing dust storm warnings initially, although we all kind of merged over to that blowing dust warning at the end. And that's all I have. Sorry I went long there.
Awesome, thanks, Jeremy. We're gonna go on to Aaron. We'll come back if you have questions for Jeremy or comments. We'll circle back at the end of the presentations, kind of in the open discussion time frame. So thanks, Jeremy. For now, we're gonna go on to Aaron at Dodge City. So Aaron, the screen sharing is coming your way. And take it away.
Right.
Thank you.
I think you should have my screen now.
Yeah, looks great.
All right. Oops, went too far here. All right. Well, do appreciate the opportunity to detail some of the key findings from the after action review for this event for WFO Dodge. Foremost here, significant credit needs to be given to Dodge City forecaster Adam Springer for not only creating a lot of the slides here, but taking a lead role on composing the local after action review. And as you guessed, we honestly have way more material than could ever be presented within 10 minutes. So again, as mentioned by others, feel free to send any questions our direction after this. So before digging too far into the findings, just a brief review of what happened in and near the Dodge CWA on the 15th. And obviously the historical nature of this event, the wind event, both directly and indirectly ran everything this day. The core event running from essentially mid-morning to late morning, although the strongest peak gusts occurred more in the late morning to mid-afternoon, and that was kind of connected more to the steam jet. And these were also not your more typical north-northwest winds, as you would see with a post-frontal situation on the high plains, but rather this west-southwest wind with obviously an associated strong downslope component that then produced the anomalously warm temperatures and dry conditions that created fire weather issues. So, what was fascinating to watch was the development of a steam jet, initially over southeast Colorado, that then subsequently progressed over western and central Kansas and up into actually south central Nebraska from late morning to afternoon, early evening. So, this not only created this large swath of 70, 75 plus mile-an-hour gusts, but these zones of 80 to 100 mile per hour non-convective gusts. Just at Dodge City and Garden City alone, the ASOS at those two sites measured 84 and 89 mile per hour gusts respectively, which broke not only the highest non-convective speeds, but also exceeded the highest convective gusts we'd ever gotten, which is kind of amazing when you think about the amount of severe convection that we've had, that this event alone exceeded that. So when looking just immediately outside of the Dodge area, we find both Russell, Kansas, and Lamar, Colorado with gusts to 100. And Lamar may have had some influence from convection, but nonetheless, I have no doubt, especially with the steam jet development, that there was probably 100 mile per hour gusts over, especially the west central and northern portions of the Dodge CWA with that steam jet. We just didn't have an AWOS site there to measure it. Also should be noted that the gust of 84 at Hayes may have actually been higher, but unfortunately, the arrival of these winds, especially with the steam jet, disrupted power and comms to where we lost data from that AWOS. So we're really uncertain how much higher the actual peak gust might have been, given that, especially in this case, Russell was 100. So it's also worth reiterating that, these winds produce these, again, anomalously warm temperatures, plus the very nature of strong downslope conditions meant we had the boundary layer just extremely dry. And so, given widespread drought plus the fuels being favorable, fire growth really since the end of the growing season last fall, created this extreme fire weather condition environment. And so by early afternoon, we had multiple wildfires in and near the forecast area. Jeremy kind of alluded to this, but easily the largest, most impactful was the Four Counties fire, with several farms along with small towns impacted in that fire, including a fatality immediately north of Hayes in Ellis County. So this is the same map that Jeremy kind of illustrated. You can see in the burn area here, and this is from the Kansas Forest Service, multiple wildfires developed during the event. But again, that Four Counties fire, the pink shading here, definitely dwarfs everything else. So another indirect impact and result of both the ongoing drought plus extreme nature of the winds was this widespread blowing dust. And, the majority of the blowing dust actually originated from portions of east central northeast New Mexico into east central and southeast Colorado, and some portions of far western portions of the Oklahoma, Texas panhandles, although inevitably had some originating from western Kansas and the eastern portions of the panhandles. But unfortunately, the reduced visibility from this dust did result in multiple traffic accidents, including a couple of fatalities. So with that basic review, let's look at what went well for the Dodge office. It's odd to say this, but NWP, both from ensemble and deterministic perspective, actually did exceedingly well ahead of this event. And not just a few days, but a week out. We were actually referencing the potential for this in our local AFD on like day 8. So social media were a little slower to ramp up until around the 11th or 12th, but a lot of that was because we had a previous critical fire weather event the weekend that kind of dominated our messaging. But again, we were starting to reference this well in advance, and that's due to a lot of the NWP. And so, from a headline perspective, both wind and fire weather related products outlined this potential pretty well by the 13th. Although, as mentioned previously, this is already being referenced in other products out to week plus. And so, just going to toss this in here. This is one key takeaway is that the ensemble guidance, such as these weather belt mediograms, I think was really critical in helping forecast staff with confidence and then subsequent partner messaging with this wind event. And again, this shows some potential out to a week ahead of time. And so, access to these charts beyond a training and awareness level is really a priority item needed, I think, for providing not only better forecast, but effective DSS. And so even drilling into the day of the event, here's the cams, such as the HER, providing high confidence of this swath of higher winds resulting from the steam jet. I mean, you can literally see the evolution of that steam jet from Colorado up into west central, northwest Kansas, and south central Nebraska. So just impressive to see that there was hints, even if somebody didn't understand conceptually what was going on, they had an idea there was going to be maybe this localized area of slightly stronger winds. And so that allowed for graphics highlighting both the wind aspect and the critical fire weather environment to be, I think, effectively communicated prior to the onset of the event. Now, on the other side of the equation, while we did issue, both a short fuse dust advisory followed by a long fuse blowing dust advisory, and we had dust in the forecast and had mentioned it, I think in all honesty, we were probably a little more reactive with the dust side and this more short fuse type of products instead of proactive. And so that's something that I realize is difficult to anticipate without either leading to kind of a high fault alarm rate by carpet bombing, say, the entire area ahead of time, or simply reacting. Because we have, obviously, it's the high plains, we have a lot of wind events, and not all of them create scenarios like this. But, nonetheless, the significant nature of the winds, which we were pretty confident on, probably should have led us to be a little more proactive with the headlines. Maybe we even started off with, the blowing dust advisory as long fuse is kind of almost like a watch product, and then target these areas more with the dust advisory, dust storm warnings. So that is a quick review of kind of some, key takeaways, but there's one more set of things I want to talk about here with not only some eye-catching images, but some things to understand that I think are important. And so, first up here, this is the 12 UTC Dodge soundings. Note the existence of a nearly 60 knot winds at the top of the normal nocturnal inversion well before the arrival of the steam jet. So obviously, just that alone tells you, we're going to have a high wind event. But if you're not aware conceptually what's going on with a steam jet, you may not understand that, as shown here in the VAD wind profile, this is between 18 and 19 Z. I mean, we have winds in that black box here on the far right side around 90 knots. I mean, you got 85 to 92 knots in there, the lowest kilometer or two. And of course, lapse rate for steeps nearly adiabatic. So this is mixing to the surface. That is amazing that you're getting, say, 92 knots at just 1.5 kilometers above the surface. So if you don't understand conceptually how this could happen, you may fail to see that, oh, it's going to be beyond 60 knots. And so, well, I don't have time to go in depth here with the conceptual model for steam jets, but we have to watch for these events. And especially at the tip of the comma head and traditionally just left of the dry conveyor belt, where you're going to get these strong mid-level winds that descend and mix to produce this belt of much higher wind speed. So, important key takeaways, we have to see this and understand that these conceptual models matter. And so, for example, John Stopcotty at North Platte, yours truly, were discussing the development of a steam jet around mid-morning. This was over kind of central southeast Colorado. And he outlined this potential in yellow on the water vapor imagery and shared this via several chat rooms. And this continued later. By early afternoon, the steam jet was really beginning to move over west central northwest Kansas. And so I drew a similar type of outline here and also shared this via chat rooms. And so, the extreme subsidence existing with a steam jet, associated momentum transport of these strong winds at the surface, if you don't understand conceptually what's happening, you might not see what's going on and be able to bump up the messaging, because it's illustrated in the sequence of true color images. Note at this time, the tip of the comma was still evident, yet within 10 to 15 minutes, the clouds were largely eroded with smoke plumes now evident. And of course, this process continued repeatedly with the tip of the new comma eroding within 10 to 15 minutes. And so you got damage like this. This looks like a severe convective event, but this was all just, mostly due to the steam jet. And this is over Scott City. I got a roof here that was ripped off and torn and obviously took out some people's fence. Obviously a lot of trampolines, but that's a different topic. And so, moving aside from that, here's a good example with the GOES 16 3.9 micron imagery of the extent of the active wildfires that were ongoing. But, sometimes you get things like dust and other things that can obscure that. And so I think it's very important to also be able to generate or create some this is a local RGB that we use that helps us highlight fire weather potential. And so I think it's important to have these type of local products too. So that's another key takeaway beyond just the understanding of the steam jet conceptual model. And of course, significant reduction in visibility from the blowing dust was everywhere. As I mentioned, that caused several accidents and a couple of fatalities. And I'm not sure where this was from. There was, I believe, over the upper Midwest, but yeah, some of that dust make it all the way up there and splatter these vehicles. So that is a really fast review of the event and key findings from the Dodge City perspective. So as I mentioned during the opening, feel free to contact me if you have any questions.
Hey, thanks so much, Aaron. Yeah, the steam jet thing was a part of the event. It's just absolutely fascinating. And I loved how you showed the satellite imagery and kind of the desiccation of the clouds as the steam jet evolved. Just a great signal. Andy just has a comment, I believe, or a question for you, Aaron. Go ahead.
Okay, sure.
Andy, let's see. You are unmuted.
Yeah, thanks, Randy, and thanks, Aaron, in the talk. I should say two points. One, I'd like to get your thoughts on, the blowing dust, and I know the impacts that it can create. Is there enough there? I know we love our products, and we already have blowing dust advisory and warning. Like, is there a good case to make for a watch, or for that product, the threat for visibility and all that can happen from it?
Yeah, that's kind of where I took a different perspective of this, that maybe the long fused, instead of looking at it, and I'm not saying that Goodland did it any better or worse, but they went more of the short fuse than the long fuse. I've kind of wondered, do we need to go with the long fuse and then target these areas with a short fuse? I I don't know. I don't know what the answer is, and I think a lot of us are trying to figure this out on the fly. And I guess my thought is our awareness may have, or at least being able to make the public aware, may have been better if we started off with a long fuse and then find these areas to target with, the short fuse stuff, whether it's advisory or warning, it's what it is. But I guess that's my thought on it, is to maybe it's a manipulation what the product's for, but that's I guess I kind of look at it as almost like a watch format first.
Yeah. Yeah, and also the consideration knowing it is the ground, or is the dirt in a position to to blow if the fields
Right.
are all stuff and all that. So, and then I love the Stingjet talk, and I'll update the science overview on this to include that for sure, because yeah, I mean, I had done some science stuff with Stingjets back in my time in Marquette, and over a decade ago or so. Yeah, these things are monster wind producers, and they're more typically things that you find over the North Atlantic heading into England, but
Right.
that's where it was coined. But yeah, they happen here too.
Yeah, I think a lot of folks were left that day when it was mentioned going, a what? Which kind of told me, okay, conceptually, we need to understand this stuff. No matter how much we're using numerical weather prediction, we don't understand why there's going to be this localized enhanced area of winds, then you're really going to fall short on some of the messaging you can provide.
Yeah, and that's a great point. And I mean, I think that's one of the challenges when you're talking about, what's pretty much a rare event, right? As far as being able to have that conceptual model at the ready and in your head, when it's something that you rarely experience, throughout your career. Definitely
Right.
One of our great challenges in the agency, and one of the examples of the training and for high impact events, low probability high impact events, right? So.
Right.
All right, thanks so much, Aaron. That was awesome. We're going to move on to Geraldine, right, and Hastings. So Geraldine, I am sending the screen sharing to you. It looks great.
All right, thanks. All right, so this will be our takeaways of the after action review and the event for the Hastings area. So a summary of what happened in Hastings. Really, Hastings was at the crossroads of a number of significant hazards, and we speculate that we had more than any other office in the Central Region. We had the widespread winds, 60 to 90 miles an hour, that were both thunderstorm and non-thunderstorm related. We had fast moving QLCS tornadoes, extreme fire weather. We had reduced visibility from not only blowing dust, but smoke as well. And we also had brief snow squalls. And then we also got the pleasure of assuming backup for Omaha while they sought shelter from their storms. And all of this happened in a 6-hour time span. This really was a historic system for the Hastings office. We issued 11 tornado warnings, with 9 of those confirmed tornadoes. Prior to this day, there were only 5 tornadoes in the entire state of Nebraska in December since 1950. And the 9 confirmed tornadoes is just for the Hastings area, so that doesn't even count the whole state. We had high wind warnings with over 30 hours of lead time. We issued 118 LSRs. I recall one of our forecasters working told another one that you will issue the most reports you've ever issued, and they were right. 8 separate hotspot notifications. We also issued for the very first time in Hastings a dust storm warning, a blowing dust warning, and a snow squall warning. And basically they're all issued very close together at once. And then on top of it, we had 1 tornado warning for Omaha and 4 SVSs issued in a 4-minute time window. And just for note, just how historic this system is for us this day, it was likely the largest number of storm data entries for a single event in our area. So I'm really going through the what went well of our event. So the forecast and warning ops, because of the fast movement of the convection, the storms, we just made the decision was made to issue tornado warnings that were limited to 15 minutes. So that it would be concentrated to small areas. They were moving so fast that if we had longer ones, it would have been really, really long path. This allowed us to have more precise threat information while also limiting the time needed for sheltering because it was there and gone in a matter of a couple minutes. We did have a warning team in place where they split the warning needs. We had a dedicated warning meteorologist and a support one. They were positioned close to each other so they could have a high level situational awareness and able to communicate with each other. We had the meso-analyst position initially. We had both. We had somebody in office and the remote meso-analyst providing from Central Region, which they also provided some assistance more with the QLCS development and the evolution of that and radar interrogation. We were able to quickly pivot and provide service backup for Hastings or for Omaha, issuing that one tornado and 4 severe statements. And this is, meanwhile, in our area, we were also dealing with the wildfires that were in our southern area in Kansas and snow moving into the western side of the CWA. We also used Graphy DSS to provide near real-time radar loops and convection, which was the first that had been used here in Hastings. This is a loop of the showing the wildfires spreading in northern Kansas. You can see the 4 county fires that's been referenced before. We sent 8 separate hotspot notifications on this day, and one that was really we got a report that was, you know, really the crux of what we do. A fire near Alton, Kansas. The hotspot message was the initial notification. And they, because of that, they said that it was key in saving at least one structure. So it was a high positive for the hotspot notifications. And throughout the event, we were able to focus, we were able to maintain our forecast and messaging focus, even though we had widespread dust and smoke and winter weather concerns develop. So our staffing, we adjusted our staffing prior to the day. We knew this was a high impact day. We knew it was a historic day. We were mainly focusing on the high winds and fire weather potential, however. We did have staff directed to come in early or cancel telework once it became more obvious that the convective risk was going to be more significant. The additional staff and the workload was adjusted quickly. Initially on the morning of this event, we were not even in a marginal, or if it was just this clipped us, and we had severe weather across our whole area. So that was a change even prior to the day and the day of. We did have great communication across the office and with remote staff operations. We did use people on telework. We believe this is due because we had defined roles and responsibilities, and we also positioned people in the office so that they could communicate easily. And then we utilized our tools, NWS Chat, Google Chat as well. Following the event, we had staff members use the DAT to input precise circulation tracks in a preliminary sense so that it would make it easier for the damage assessment meteorologists to find where to look for those tornado tracks. For our partners and partner services, we did do a partner webinar at 11 a.m. on the 15th, and we focused in chunks of 2 to 3 hour time periods. We did that so that the partners would understand the different time periods of this event. There were a lot of impacts to schools with buses, post-school activities and stuff, and this was something that not all of us had thought about initially. We had a lot of social media posts, and some of our partners noted that the mention of historical wind event during the briefing that morning at 11 was significantly impactful. That was mentioned that Merle, who worked the event, he had never seen anything like this before, and that provided context for our decision makers. We also had a post-event summary webpage that provided a quick one-stop shop for the event for our emergency managers and public. It gave information as wind gusts and tornado paths. So what could be improved across the board, from locally to regionally and nationally? There's a general lack of awareness of severe convection potential in our area. Now this is image on the right here is the 13Z outlook. So we did, this did get expanded westward, and we were included in at least a slight risk, and we highlighted the area in red where we thought would be the highest impact. But if you know our CWA, this is about 30 to 100 miles, 30 to 50, I don't know, a few counties, what we were expecting for severe weather, and it really started and tracked across our whole area. There was some high resolution models that depicted this convective trend, but we barely had thunder mentioned in the forecast the day before. The tornado watch was issued, but by the time it was issued, we were already in warning mode. We had 3 severe thunderstorm warnings, and they're moving at 70 miles an hour. Within 40 minutes of the watch, 6 tornado warnings had been issued. So for a lot of areas, there really wasn't any watch for lead time. We did not have a partner webinar the day before. We expected high winds and extreme fire danger, and we underestimated just those impacts to our partners. Honestly, we needed more staff in the office, and we needed them sooner. We did make adjustments on the day, early on that day shift, and we brought people in, but we didn't expect the convection to begin when it did and as far west as it did. And so that really was something that changed, and we could have used more people. The extreme nature of the event pushed us to the limit. Personally, I worked the event. It's one of the busiest 4 hours in my entire career that I've ever worked. We had a recommended number of people for the operational staff, in our level 1 playbook, but the rapid evolution and speed of the event, combined with all the impacts, it really taxed us to the limit. Some other things that can be improved with the warning forecast side. The remote mesoanalyst was not activated early. In fact, I requested it to the ROC not long before we started warning operations, and it was extremely impactful, so it really was useful. We just wish it would have been activated earlier. The main focus, though, was east of the area initially, despite the presence of tornadic convection in our area. Due to the fast-moving storms, the short expiration time of the warnings that we chose, we were unable to update the tornado warnings with the required SVSs in the middle. By the time we had a chance to do that, we were within 10 minutes, and the software limits that ability. So we're not able to issue statements. It was basically warnings, initial, and cancellations. We did use Sales 3, but we also acknowledge that maybe we could have used the Merle scans for the tornadic storms near the area, but honestly, this was moving so fast, it would have been a challenge to switch. In preparing to back up Omaha, we had some issues with getting their data with RMR. We also had some of the initial tornado development near the wind farms, and while that didn't significantly impact warning decisions, it did add additional clutter. We utilized multiple workstations that staff maybe had not used very much in the past. So it led to delays in logins and just some lack of familiarization with the PCs, of knowing, getting bookmarks, stuff like that. Took some more time. We feel that, in the post-event, we could have some more formal conversations, maybe between different forecast offices and the ROC for post-storm damage assessments. So maybe we could utilize maybe mutual aid a little bit better and provide a better coordinated look for our partners in the media. We had a little bit of confusion with our damage surveys about how many tornadoes occurred in the state and the historical context. We had some action items. We need to include requesting RMA if it's not already requested in our playbooks. We want to try to encourage staff to log into the different PCs at least once every 6 months to help lessen the frustration when they're asked to sit somewhere they're not routinely sitting. Want to place a focus on non-traditional extreme events such as the high wind and fire, so we can proactively promote the webinars earlier since we only had the one on the day of. And we want to have the staff to be more aware of the marginal convection on the cold season and more qualitative probability messaging of the events. And we want to look at promote the importance of adequate staffing for all high impact events and use all in-office and network and telework employees and use the playbooks. We continue to recommend for our best practices, we utilize the playbooks and a warning team. We feel that was really successful. We also recommend that for high impact events, the staffing roles are clearly identified, which is one thing that we were able to do. We felt that in this situation with the high speed of the storms, that the 15-minute tornado warnings were a positive because despite the limitations, because it really focused the area that needed to be warned. We recommend using all staff as available for post-event information, whether it's storm damage assessments to gathering information, social media posts, and media inquiries. And we recommend utilizing the DAT kit as first guess with the circulations tracks. And then we also thought it was really positive in our partner briefing that we had, instead of just an overview of the storm, we did 1 to 3 hour time frames to help draw the important events in that time frame for each area. It gives the partners more clear time information and helps with their decision making. So with that, that's all I have.
Excellent, thanks, Geraldine. So much to unpack. Your CWA, like you mentioned, truly was kind of at the crossroads of the event with so many different impacts. A couple of things stood out to me. Well, many things stood out, but a couple I'll make comments on. As far as the RMA activation, that was a really good point. I remember reading the chat that day and some of the discussion that was going on regarding your CWA. We are expanding our cadre this year by about 12 folks, so hopefully we'll be able to provide coverage for more events and for greater time windows. And your comment about the warning limitations really stood out to me too, because I think that's something that we need to address at a national level, as far as not being able to update when you get in that 10-minute window, because sometimes you have like really significant information potentially to share, right? So I took a note down on that to follow up and see if there's anything that we can start having a dialogue nationally about that particular limitation. So we'll circle back. Thanks, Geraldine.
Thank you.
Yep, thank you. And we'll circle back again to the open discussion right at the end. But now we're going to move on to Jenny Pittman, who is the Sioux in Topeka. Jenny, the screen share is coming your way.
Okay, I've got it. And I will talk more about the RMA as well, but I definitely think the breadth of the system that we're seeing from all of our different presenters, both this week and next week, kind of describes some of the issues that we did have with activating the RMA. I think we ended up having Chauncey in there helping lead it, so we had to look all the way to North Dakota to find someone that wasn't impacted by this system. So we're moving to the Topeka area now, and we'll talk a little bit about some of the challenges and successes that we faced in our forecast area. So just looking at how we were leading up to the event, and this is similar to our partners to the west and northwest. Well, we started out with a fire weather watch that was issued on the morning of the 14th, and that was valid for the 15th. And then also a high wind warning for those synoptic winds out ahead of the system, where we actually did have some pretty high dew points, but still some really significant winds. And then a red flag warning was issued the afternoon of the 14th in preparation for the 15th. We did end up conducting a partner webinar on the 15th, focusing mainly on the high winds and fire weather. Like Geraldine showed, there were some adjustments to the convective outlook, and severe weather, while it was mentioned in our webinar, was not the primary focus and was actually not advertised in the title. And that was actually one of our findings that I'll mention later. But by advertising it that way and focusing mainly on high winds and fire weather, we really didn't get a lot of participation in our partner webinar. So that's something to look at in the future. We did get a lot of partner questions about the severe risk as it started shifting south. There was an adjustment closer to our area with each issuance, both the initial issuance for the day one and then the 13 and 1630 kept bringing that a little bit further into our area. So we did have a lot of questions about that and what that meant for the severe risk for areas that were right on the edge. And so we did have really continual coordination with the Storm Prediction Center and then also our neighboring offices that were kind of on the edges of that risk as well, to help keep everyone aware of how things were changing as our mindsets were also changing. So a summary of what happened in our area: deep convective initiation first started in Goodland's forecast area. The initial movement of that convection was to the northeast and moving into Hastings area. But then storms began developing farther south along the boundary between 19 and 20 UTC. And in total, that ended up spreading across our entire forecast area. So in total, we issued 17 severes. It doesn't seem like a ton, but the storms were moving very quickly. Most of our storm motions were between 55 and 65 miles an hour. So 17 actually covered our entire CWA. And 13 of those 17 severes indicated the destructive tag for 80-mile-an-hour winds. We also issued 4 tornado warnings, which I'll talk about in the next couple of slides. But in total, we ended up with 10 hail reports. Our largest was 4 inches in diameter. We never got a picture of that, but like I'll show, it was a pretty robust supercell at that time. And then 58 reports of thunderstorm wind, with our highest gust that we could attribute to a thunderstorm at 85 miles an hour. So this is pretty early on in the event, about an hour after things started getting into our forecast area. You can see a pretty cohesive line. Our QLCS structure starting to move across the forecast area. And while you can see some areas of enhanced convergence, overall, it looks pretty linear. I turned off the warnings so that you can actually see the radar, because we did have warnings throughout the length of this QLCS. But earlier in the event, looking at a pretty linear structure. But even 20 minutes later, we started to see some breaks in that line, some embedded mesovortices, some areas that were bowing and starting to break apart. So these were the things that started to prompt these 4 tornado warnings that we did issue. And there was also heightened awareness based on what was happening in Hastings area at the same time. Obviously, the environment was very conducive as well. We didn't even have to look at what direction the 0 to 3 kilometer bulk shear vector was oriented, because regardless of how this line was moving, it was going to have at least 30 knots and then some to spare. But we did start to see, this was probably our best QLCS circulation. Again, I did leave the tornado warning on this one just so you can kind of focus in on the area. Pretty good depth with the circulation as well. We didn't ever end up getting any tornado damage from any of these circulations, but it was very difficult to survey, mostly because we had synoptic winds out of the south to start out with. Those were 60 to 70 miles an hour. The winds from the storm were from the southwest to west. And then we had some strong 60 to 70 mile an hour synoptic winds behind the storms as well. So damage in multiple directions regardless. And we weren't able to pick out any specific tornado paths from these, but obviously quite a bit of damage from the winds, both in the thunderstorms and from the synoptic winds as well. And then as we move forward in time, so this is about 3 hours after things got into our forecast area, you can see that line starting to break apart. And we're actually seeing a transition, not the transition you would expect where you have supercells going to QLCS, but actually QLCS transitioning back to a supercellular mode. And this was as the shortwave trough started to move out. We start to see our shear vector changing a little bit, starting to see more directional shear, and we start to see these supercellular structures breaking out from the main QLCS. And this is right as it's getting to a lot of our population centers along I-35 and along I-70. And so you can see one of the supercells that broke out near Emporia. We're looking at base reflectivity at 0.5, 2.4, and 3.1. So you can see a really nice beaver aloft here south of Emporia. Also the rotation at the mid-levels. So really traditional looking supercell that's breaking out from this more QLCS event. And this was really a mindset change as well. You know, we knew the shear was strong throughout the whole event. But as it started to transition to more directional shear and we started to see these more supercellular structures, we really had to refocus what we were indicating in our warnings, upping the hail size, just kind of refocusing on the threats. However, we did have some pretty cold, pretty wet RFDs with these supercells. This is that Emporia supercell as it continued to the northeast. You can see perhaps an area of rotation south of Pomona, but it's in an area of low signal to noise ratio. There could be some issues with the data there. And just this huge, really cold, wet RFD near Quenemo. So we were not thinking there was a whole lot of tornado threat with this, mostly because of that super cold RFD. But we did have some partner and private agencies that were thinking this was a little bit more of a tornado threat than we were. So there was some confusion with the specific storm and some private agencies indicating that there was a tornado threat where we were indicating that there was not. We also had the fire weather that our partners to the west were indicating as well. So we were anticipating a significant fire weather event behind the boundary that was coming through behind the storms. And you can see in this graphic, this is the 25-hour HREF mean surface relative humidity forecast, and then the 1-hour forecast. So this is from the 0Z run on the 15th and the 0Z run on the 16th. And you can see what was originally indicated was that our RH values were going to drop below 20%, possibly even below 10% as those storms pass through. But what ended up actually happening is that a lot of those lower relative humidities stayed to the south. Goodland described how that didn't really make a difference for them, but fortunately the reduction in, or the non-reduction in relative humidity as well as the time of day really kind of helped us keep that fire behavior under control as we moved into the overnight hours. So most of the grass fires that we did see were actually ahead of the storms, ahead of the boundary in those strong southerly synoptic winds, and those were able to be controlled before the frontal passage, before the wind shift. And we didn't really see any extreme fire behavior afterwards. However, we did get the smoke. So after the storms passed through, we had some really strong westerly winds that were advecting the smoke smelt in from the 4 counties fire. And we had been messaging our fire concerns pretty heavily throughout the day and the day prior. So we had a big heightened awareness of fire concerns and that fires would be possible. So we had a ton of public reports once the smoke smell started coming in. Douglas County mentioned that their dispatch actually went into overload with fire reports and questions, and Johnson County, who's in Pleasant Hills area, reported that as well. There were tons of people that were calling in thinking there was an active fire, and many of the departments actually sent out patrol units to look for active fires because they were thinking that it was located near them. So we did put out this tweet, and it did help clear things up for a lot of the public, but things that we could have done differently, maybe having our partners advertise this as well, maybe even advising that to call dispatch unless they were seeing an active fire. Some of those things might have helped as well, and something that we will account for in the future if this ever happens again. So as we're looking at our AAR, we wanted to make sure that we incorporated kind of the HSEEP process. We're looking at our best practices, but then we want those action items to also go into an improvement plan. So we had 8 total findings in our AAR. 3 of those were best practices and 5 of them were assigned as action items in the improvement plan. Our best practices included leading up to the event. Central Region STI really helped with some science sharing presentations. It's similar information to what Andy presented at the very beginning. And this really helped because we have a lot of teleworking staff leading up to this event. We have people in the office obviously as well that are looking at this, but it really helped fuel a discussion. We were talking with teleworkers, with staff that was in the office, and really helping get our situational awareness built up leading up to this anomalous event. So that was really a best practice where it helped us realize that this event was going to happen, and then helped confirm some of the things that we were seeing in our conversations. We did have actually 2 dedicated in-office mesoanalysts. We had one for severe and one for fire. The person that was doing fire was also going to be issuing hotspot notifications if necessary. But that was a really great staffing model, because the person that was doing fires was able to look at more of the synoptic and regional setup as well, and feedback with the severe mesoanalyst. And then we were using the RMA program as well. Like Geraldine said, it was difficult to try and spin up initially, but the support that was provided was really helpful for our office, and we were able to communicate that. Even without a dedicated facilitator for the RMA program, we were still able to take the things out of the room and really use them within our operations. And that was just really necessary as the severe risk grew beyond what we were initially expecting. We also had on-site support at the Kansas EOC. Our WCM was deployed there starting early that morning. And that really reduced the workload, not only at our office, but hopefully at the other Kansas offices as well, because they were dealing with so many things going on simultaneously, fires, severe synoptic winds. So he was really able to streamline that information from all of the Kansas offices and prevent, hopefully, a lot of calls and questions coming into each of the forecast offices that were being impacted with those different hazards at the same time. And then for our improvement plan, it's important to note as we look at the improvement plan, this was our biggest severe weather event in 2021. We've had abnormally inactive severe weather seasons both in 2020 and 2021. So some of these improvement plan items are related to knocking the rust off. And so I'm not going to outline them. I'm more going to summarize them because some of them are a little more internal. But some of it does relate to the fact that it's been pretty quiet over the last couple of years for severe weather. So the 5 action items that we did identify were tied to our communication with our partner agencies and some of those private entities that do have the capability to analyze radar data and make their own decisions. So we'll continue to work on those partnerships. They're also tied to collaboration, not only internally, but also with our neighboring offices and our national centers, as we are all sending out the same message and want to make sure we're all on the same page. Increasing our reach for non-traditional webinars, like we talked about, we really didn't have a ton of people on our webinar for that fire and high wind risk. So that's something that we want to continue to work on and make sure that we still do have partners on those webinars and that they are valuable to people. And I think the more that we do that aren't for traditional moderate risk or winter storm warning, I think will help in the future as we start to do perhaps more of these. And then reviewing our IDSS duties, again, that relates maybe to a little bit more of knocking the rust off and making sure that everyone is up to speed, and also making sure that our IDSS duties that we've indicated in our severe weather operations plan match how IDSS has evolved over the last couple of years. So these action items were all assigned to someone, mostly to myself and to our WCM, but also our social media focal point. So we'll be reviewing these at our severe weather seminar in March to make sure that we're still on track with that IP. And that is all that I have.
Awesome, thanks Ginny. Great material and fascinating to see the different perspectives from all the WFOs. We'll circle back to you, but I want to move on right now to the next presentation. So we have Scott Blair, Senior Forecaster at WFO Pleasant Hill. Scott, I'm sending the screen sharing over to you.
Okay, very good. Thanks, Randy. Everything look good on your end?
It does, looks great.
Okay, awesome. Well, hey, thanks for the opportunity to present today. And really a big kudos to all the offices that have gone before us. It's been pretty fascinating to watch it from west and northwest of us approaching us. So I won't kind of rehash everything that's been covered. It was a pretty dynamic event, and for us, we did have our local impacts as well. Moving into just the, if you will, just the surface winds out ahead of the convection. Certainly not the type of wind speeds we saw to our west and northwest, but still pretty strong for this part of the country. Just again, in the Kansas City metro alone, we had several measured reports between 71 and 58 miles per hour. And while, again, it wasn't necessarily as windy as points west, it was kind of fascinating since we have a lot more trees. It was pretty littered across this area with tree limbs down, some trees uprooted, even outside of the thunderstorms that we had. So that alone was an impact leading up ahead of the convection itself. Additionally, of course, we had our severe weather threat. The map on the right is just a collection of our LSRs across the area, kind of highlighted where some of the strongest winds we had up in our far northwestern sections of our CWA, and that we had several measured reports of 80 to 90 mile an hour winds up there. But also we included that in the severe thunderstorm warnings with the destructive tag with those. But a pretty good variety of both non-thunderstorm and thunderstorm wind reports. We even did have one wildfire across part of the Kansas City area that kind of spread just off the interstate. So what went well? We'll kind of talk about that as well. So social media wise, this is just kind of a overview of both impressions on Twitter of what impressions, just what appeared on folks' screen versus engagements where they actually either reshared or liked or whatnot. We really maintained a pretty active social media presence, both leading up to the event and during the actual severe weather event. And that's really something that here locally we really try to pride ourselves on is even outside of busy weather, we try to consistently get and build engagement to kind of have those relationships with those that follow us. So once we do get into severe weather or some kind of high impact mode, we've kind of already had that audience built and those relationships built. And I think we kind of were able to see some of the fruits of that with this event. You can kind of see on the left graphic here with the impressions, pretty good spikes when we posted either the tornado watch, later on we had a severe thunderstorm watch we retweeted. We provided a radar update as storms were beginning to march towards Kansas City. And then of all things, really the fire interest was the highest impression and engagement, kind of in that salmon star color. We had 76,000 impressions on that, and you can see the tweet on the top there. And there's a lot of interest in that, and it was pretty thick smoke across Kansas City. And again, the metro alone is just shy of 2.5 million people. So that was a lot of people that were not only being impacted by these very strong winds out ahead of thunderstorms, but then even smoke. A lot of media interest was being garnered with this event from the wind and the smoke, and that the tweet alone, even without a graphic, did quite well for us. From a warning perspective, this is something you always love to see, right? IEM Cal on the left, lots of green. We'll take that any day. In fact, one of the reds there on the severe is probably just a lack of really population to get some information. But for us, we had 16 warnings, 14 severe, 2 TOR, 13 of those verified. So again, we'll take that any day. Real good lead time. We'll kind of talk about that. That's map on the right is just all of our polygons that we issued. To no surprise at this point, it was pretty much the entire CWA by the time it was over. We really did, Jenny mentioned earlier in the previous talk, we had some really rapid storm motion with the line of storms that came through, anywhere from 55, 65 miles per hour. And that really necessitated us to do some large polygons. And also, while we were at it, long duration warnings with the high confidence that we had in both the line maintaining itself. We were able to kind of watch the behavior of the line as it moved through Topeka's area. We had pretty good confidence that it wasn't going to just fall apart. So we were able to do several 50, 60-minute long severe thunderstorm warnings and really provide some good lead time. And that translated fairly well with the average lead time of 36 minutes for our CWA. Jenny mentioned in her talk too, just beforehand, that while we did have a pretty good line approaching our area, we did have a window, presumably when we did have strong deep layer shear increasing SRH, where we really did have some supercellular-like characteristics that began to kind of evolve just west of our area and in parts of our area. One of those was across northwest Missouri. You can see just the radar image there. Both of this is 1/2 degree off of the Pleasant Hill radar. We did issue a tornado warning for this. We did have a decent couplet that maintained itself for a while, but at least nothing reported. Again, it would have maybe been difficult in that area to even differentiate between the damage from the winds we had ahead of the line versus actually the storm itself. But nevertheless, we did have some things that certainly piqued our interest in that regard. I think Jenny also mentioned the supercell that was coming out of Emporia. This is kind of a time series of, again, 1/2 degree off of our radar over roughly a 30-45 minute period. And it was a very healthy storm as it was approaching our CWA. Of course, we issued a severe for that. At the time, we kind of started out with a max hail size of 1.5 inches. As it became obvious that that supercell was going to kind of maintain its structure, at least we presumed it would, and with more reports coming out of the Topeka area, we went ahead and increased that to a tennis ball size hail. And again, with the winds we were expecting, 70-mile-an-hour winds. Now this is moving into parts of Johnson County, and Johnson County alone has 600,000 people. So as you can probably tell on the radar imagery, this storm fortunately started decaying rather quickly as it moved into the Kansas City area. But if it would have maintained its intensity when we first warned, where you were looking at, tennis ball hail or even larger, moving into, 500,000 population center along its track, that could have actually been a pretty big story. But fortunately, that weakened as it moved into the Kansas City metro. All right, so for us, what could have improved? Well, one of the biggest challenges, and Geraldine and Jenny talked about this, was really for both SPC and us locally, trying to really get a good handle on the southern extension of the severe weather threat. That was quite the challenge. Taking a look at just the day one graphic here, from 6 UTC to 20 later on in the day, you can see a pretty good extension of the slight and enhanced risk. In fact, the enhanced risk was dropped roughly almost 200 miles south. So that did kind of play some role in anticipating what we might want to do with our partners. We did not schedule a webinar with partners with, again, the main fire weather risk west of us. The high wind was covered in other types of communication lines. We didn't have a severe themed webinar with that. But what we did do, and we've done this for quite some time now, we issued the DSS packet twice a day, daily, regardless of severe weather or high impact weather. We've done that since 2013, and we've really found that as a good mechanism or really a vehicle for our partners to always count on. Okay, you're going to get an update in the morning, you'll get an update in the afternoon of exactly what we're thinking. So we had that going for days in advance with this type of event, with a little bit more detail and some graphics with that. And then as things became a little bit more obvious in the afternoon that the severe weather threat was ramping up, we did do an email blast with all of our partners, school superintendents, to let them know what our very latest thinking was, to try to get them some heads up. Workload was extremely steady during the entire event. The only thing we probably had that was a little unusual for us is we were on 3 different NIMNAT calls during a 5-hour period, each of which lasted roughly 8 to 10 minutes. So, that just kind of happens, and especially when it is a challenge to try to figure out to maintain, how long is the southern end of severe weather going to maintain itself as it moves eastward. We were all kind of playing a little bit of catch up, but that certainly did increase a little bit of workload for us being on the call for that period of time. And the only other thing too, we did have a high wind warning, as most people did with this event. But the way we had it configured prior to this event is it would automatically tone the high wind warning out through weather radio. And we had a couple days, about a day and a half in advance, we had some fairly unhappy users being in the middle of the night awakened at 4 in the morning or whatever it was. So that was something that we've made a change now to be able to send that over manually a little bit later in the day to not try to wake up folks unnecessarily at 4 in the morning. The only other additional findings that we could probably mention, RMA support, we did not necessarily use that for this event, but it would have been a pretty useful supplement to our operations. I think that's something that we'll certainly look into more as we continue to move forward. We do have the AR report internally with the staff, and we're going to chat about it a little bit more with a brown bag next month with everybody. As Jenny mentioned, several others mentioned, it's been a fairly quiet last couple of years for active severe weather. So this really did provide an excellent opportunity for us to be able to make sure everybody's on the same page moving forward and continue to learn together as a team. And then also, you know, we used several different methods of communication. Of course, we mentioned the social media. We do have a MERS radio for the Kansas City Metro. It's our local emergency radio. That's extremely useful to both fire, police, emergency managers across the Kansas City metro area. We use that pretty regularly to give updates of when the storms were expected to arrive, what those impacts were, and then also to share reports back and forth. Of course, again, we had our decision to support packets that we sent out, the email blast, and of course, all the legacy products. All of that really helped provide a nice flow of information back and forth, and we were pretty pleased with that. So I don't want to take up too much time. That was kind of our local perspective in a nutshell. So I'll turn that back over to you, Randy.